All right, we're going to look at continuity of functions. All right. To be continuous, the limit as x approaches a for f of a must equal a value. Let's say b. Okay. You have to have a value there. Okay. Must equal something. And that's from the left and the right. And then f of a must equal b for every point on the function. Okay? So it's not continuous if the limit as like x equals, as x approaches 2 of f of x equals 4 when f of 2 equals 2. Now you're going, what does that mean? Okay, so 1, 2, 3, 1, 2, 3, 4. So we might have a function that looks like this, that goes like that, and like that. Okay, this function is not continuous. It has a value for every single x. Okay, because when x is 2, it has a value. When x is anything but 2, it has values along this function. Okay, but this is not continuous. So a function like this is continuous. Anywhere along it, you can find the limit of a point, and the value of that point is going to be equal to the limit at that point. That's what a continuous function is. It has to meet both criteria. Okay? So, this is not a continuous function. Okay? Because it has a hole in it. Now, what type of discontinuity is it? Some of you that worked ahead figured out that this is a removable discontinuity, okay? When it has a hole. There's other types of discontinuities. When we have an asymptote, okay? This asymptote makes a discontinuity, okay? And he calls it an infinite asymptote, so an infinite discontinuity. And then there's the discontinuities that go like this. Okay? Where it's a jump discontinuity. So you have the jump discontinuity, the infinite discontinuity, and the removable discontinuity. Now, we're going to get to problems where the graphs aren't there for us. Okay, no graphs. So y is equal to x plus 1 when x is less than or equal to 1, and then 2x minus 3 when x is greater than or equal to, one of these, let's just do a greater than on this one. Greater than 1, okay? So what you're going to have to do is either do a table of values. So we'll take this, make a table of values. -1, 0, 1. At -1, we are at 0. At 0, we're at 1. At 1, we're at 2. And then do a table of values here. And go 1, 2, 3. And this one is going to be an open circle because it's not equal there, but we still need to find the end one. If we put in a 1, we get 2 minus 3, which is -1. Put in a 2, we get 1. Put in a 3, we get 3. So as a graph, and not that you have to graph these out, but just so you have an idea what you're looking at. -1, 0, 0, 1, 1, 2, 1, -1, 2, 1, 3, 3. So this function looks like this and like this. Okay? What type of discontinuity is this piecewise function? It's a jump discontinuity. Okay? Now, sometimes on these piecewise functions, they'll overlap each other. Okay? So if we look at this, y equals x when x is less than 0. So it's open circle at 0, -1, -1, -2, -2, -3, -3. It goes like this. And then for this one, we're at like 1, 2, 2, 4, and so on, going down like this. And because it's equal to, then it fills in the circle that it overlapped. So is it discontinuous or continuous? It makes it now continuous, okay? Because they start and end at the same spot. So there is no discontinuity on this. So you'll see some of that. So that'll be the algebraic ones. That'll be piecewise functions that you'll have to figure out, okay? And then you'll have to figure out what discontinuities we have. And just looking at graphs, figuring out what the various discontinuities are. Okay, so that's the rest of the sections. So get working on that.